squared. So f of x equals 3x. In using first principle, by definition, we know that the derivative of a function given in x, where the limit h approaches 0, where h is the small change, this is given as f of x plus h minus f of x, all divided by h. We know this as the definition, or let me say the formula for finding the derivative using the first principle. We have our f of x, so we need to find f of x plus h. In studying functions, you know when we have f of x given as a function 3x, the moment we have f of x plus h, we know x plus h replaces x in the function. So this gives us 3 multiplying x plus h. Then we can expand this by writing 3x plus 3h. All right, so now we have our f of x plus h. We also have f of x. So we can just substitute this in order to find the derivative. This was h approaches 0. This becomes 3x plus 3h, which is for f of x plus h. Then minus f of x, which is 3x. All this divided by h, and we know h approaches 0 here. So let's move on. We have 3x plus 3h minus 3x. So this becomes 0, positive 3x, and then negative 3x. That becomes 0. Okay, so this gives us 3h divided by h. And we can easily cancel out our h or divide through with h. And our function f of x becomes 3 as our answer. So this is what we have for the first one. Number 2, f of x equals 2x squared. Again, we know the definition that the derivative of a function f of x is given as the limit h approaches 0. This gives us f of x plus h minus f of x, all divided by h. We have f of x, so we need to find f of x plus h, meaning f of x plus h, this becomes 2, then into brackets x plus h, all squared. To make it easy for us, let's first expand x plus h all squared. We have 2, and expanding x plus h all squared, this gives us x squared plus 2xh plus h squared. Using the binomial theorem to expand all, you can expand them with 2 brackets. Then we can expand this to giving us 2x squared plus 4xh plus 2h squared. And so this gives us the expansion for f of x plus h. Now that we have our f of x, we also have f of x plus h. We can easily substitute into the formula. So our gradient function becomes the limit as h approaches 0. Our f of x plus h is 2x squared plus 4xh plus 2h squared minus f of x, which is 2x squared. All this divided by our small change, which is h. So positive 2x squared and then negative 2x squared becomes 0, right? So we have 4xh plus 2h squared, all divided by h. And mind you, this still with the limits as h approaches 0. So let's factorize h out and then do some cancellation. H out, we have 4x plus 2h. You know this was 2h squared, right? So all this divided by h. Then we can cancel out this. We still have h in our function, and we know it's with the limit as h approaches 0. So meaning wherever we see h left in the function, after doing this cancellation, we can now substitute it with 0. This is divided by 1. Okay, so our gradient function now becomes 4x as our answer. This is what we have as our answer, because 2 times 0 gives us 0 plus 4x. We still have 4x divided by 1. The third one, we have f of t equals t plus 3